Hello, I'm Alannah and a 7th grade student at Harrisburg Academy. This year for my science fair project, I've decided to test the process of rehydrating dried fruits. To start off, I began questioning what water temperature is most effective when rehydrating a dried fruit. When rehydrating a dried fruit, I predicted the most effective water temperature used would be 80 degrees Fahrenheit, with the most success on strawberries. Initially, I expected the strawberries to have the most success while testing because I believe that the smaller and less dense the fruit is, the quicker it would rehydrate. I also thought the 5 strawberry crisps would be enough to be able to soak up the water only to an unnecessary amount, leaving a large lessening of water left over. I had not accounted for the fact that anything can be overdone, and so strawberries can be overhydrated, or, in other words, soaked to an exceeded expected point. I expected the heated water to evaporate, then by reaching the roof of the container, the lid, condensate the water molecules back down into the fruit in smaller portions at a more controlled, relaxed pace. However, I noticed that not all water molecules had gone through condensation and remained on the underside of the container lid after the trial. I anticipated for the condensation in trials involving warmer water would help the process work more effectively, rather than only letting the water overwhelm the submerged fruit alone in trials involving colder water. The data I collected from this experiment did not support my hypothesis. One correction to my hypothesis is that mangoes have been proven to rehydrate with the most success in an experiment. It had not been with the greatest water temperature, but instead the medium, closer to the average room temperature of 60 and 70 degrees Fahrenheit. Now, what brought my attention to this experiment idea was my enjoyment of working with different foods and trying new ways to incorporate them into dishes. This experiment taught me how the properties of different foods, more specifically fruits, affects how much water is absorbed, and how much different water temperatures can impact that food as well, giving me a general idea of different measurements I can use to change any future dishes I might cook. The change to dried fruit experiences resulting from the experiment is irreversible. Though there are ways to re-dry the fruit, it will not return to its exact state as it was before it underwent the experiment's effects on it. After analyzing the data gathered from the trials, I've learned that the smaller fruits, more commonly in warmer water, had faded coloring and became more fragile and with a more mush texture. This occurred for 2 main reasons. The first reason is due to the overwhelming amount of surrounding water entering a small fruit. The second reason is because of the heated water and moisturized air softening the fruit to an extent further than preferred to reach the desired state of a properly rehydrated dried fruit. According to the results from my testing, temperature changes would most likely remain very close to the starting temperature, with only a difference of about 2 to 5 degrees, whereas some dropped or even increased up to 10 degrees Fahrenheit. Contrasting to my hypothesis, however, leftover water did not drop drastically. In fact, the water levels did not decrease by a noticeable amount. I observed very little to no changes when measuring the water while collecting data. Throughout my trials, I've collected information regarding minor and larger changes in both my quantitative and qualitative data charts. I would like to give a big thanks to my mother for going out of her way to purchase materials that I needed when I was unavailable to my friends for motivating me, for helping me out by answering any questions about the project here and there, and my science teacher for assisting me with advice and guidance regarding my project. Thank you.